Welcome students. So this is the last exercise of NCERT set theory, exercise 1.6. So we'll solve exercise 1.6 today. First problem of this exercise is this one. If x and y are two sets such that number of this notation implies number of element in x is 17, number of element in y is 23 and number of element in x union y is 38. Find the number of element in x intersection y. So we know one formula that for two set A and B, one formula is there. Number of element in A union B is equal to number of element in A plus number of element in B minus of number of element in A intersection B. Now here it is given in xy form, so we will apply that formula, that number of element in x union y is equal to number of element in x plus number of element in y minus of number of element in x minus x intersection y. So from that, put the value of number of element in x union y, that is 38, in x 17, in y 23, and this is unknown that we want to find. Now bring that number of element in x intersection y to left hand side and bring 38 to right hand side. This is equal to 40 minus 38. So our answer is number of element in x intersection y is equal to 2. This is the answer of question number 1. Next, come to the question number 2. Question number 2 also same problem. It is also given if x and y are two sets such that x union y has 18 element, x has 8 element and y has 15 element. How many element does x intersection y have? So first write the given data. Number of element in x union y is equal to 18. Number of element in x is 8. Number of element in y is 15, and we have to find number of element in x intersection y. How many number of element are there? Same formula as in number 1 we will apply. That is number of element in x union y is equal to number of element in x plus number of element in y minus number of element in x intersection y. Out of 3 known data, this is 18, this is 8, this is 15, and number of element in x intersection y unknown. Similar procedure, number of element of x intersection y, that will be 15 plus 8, 23 minus 18. So our answer is this, number of element in x intersection y is equal to 5. So how many element does x intersection y have? So x intersection y have total 5 elements. X intersection y have 5 elements. This is the answer of question number 2. Now question number 3. What is given? Check that. Question number 3 also same problem of same property. In a group of 400 people, total number of people is 400. 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? So we have to denote this. Suppose H is the set of Hindi speaking people, and E is the set of this is the set of English, those who can speak English. Now from that we can say that n of H, number of element or number of people in that set is 250, and number of element in E is equal to 200, and one more data is given, the total number of people is 400, that is number of element in H union E, that is equal to 400. We have to find number of people that can speak both Hindi and English, and imply intersection. So we have to find number of people who can speak Hindi and English and imply intersection in case of set theory. This one we have to find. So same formula will apply, that number of element in Hindi union English, that is Hindi speaking people and English speaking people, that is equal to n of H plus n of E minus n of H intersection E. This imply, put the value now, this is 400, this is 250, this is 200, this is unknown. Now let us calculate here. N of H intersection E will be 450 minus 400, that is n of H intersection E is equal to 50. So our answer will be 50 people can speak both Hindi and English. Hindi and English. This is the final answer of 3. Next, up to question number 3, we find some element in some intersection, of two sets. In this problem, we will find element in union of two sets. See the problem, read the problem. If S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T has 11 elements, how many elements does S union T have? This is question number 4. So it is given number of element in S is 21, number of element in T is 32, number of element in S intersection T, that is equal to 11, and our target is to find S union T, this element, number of element in S union T. We will apply the formula, number of element in S union T is equal to number of element in S plus number of element in T minus number of element in S intersection T. So this is equal to 21 plus 32 minus 11. So 53 minus 11 is equal to 42. So S union T have, sorry, this one 42 have 42 elements. This is the answer. So question number 4 is we are finding the number of element in S union T. Next question, question number 5. Read the question number 5. It is given if X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements. How many, this is one spelling mistake is there, how many elements does Y have? So out of 4, 3 given, 3 data given, we need 4 data for that for solving. So here 3 data given. Now check that number of element in X. X has 40 elements. Number of element in X union Y. X union Y has 60 elements. Number of element in X intersection Y. The common element of X and Y is 10. How many elements does Y have? Our target is to find number of element in Y. So we know that n of X intersects X union Y is equal to number of element in X plus number of element in Y minus number of element in X intersection Y. So this is equal to 60 is equal to n of X 40 plus this n of number of element in Y unknown, and this is 10. So number of element in Y is equal to 60 minus 30, that is equal to number of element in Y, that is 30. Number of element in Y is 30. This is the answer. Next, question number 6. In question number 6, it is given in a group of 70 people, total number of people 70, 37 like coffee, 52 like tea, and each person like at least one of the two drink. That implies there is no person out of these 70 that who like nothing or none of this. How many people like both coffee and tea? This and tea, both coffee and tea, that implies you have to find the intersection of that coffee and tea, intersection of that two sets. So first we are writing that C imply C is the collection of people. We are writing C, this is collection of people who like coffee. Then therefore n of C will be 37, and next one capital T is the collection of people who like tea. That implies n of T is equal to 52. This is India. So now it is given total number of people. So number of element in C union T, either coffee or tea, is equal to 70. What we have to find? Number of element in C intersection T, both tea and coffee, both coffee and tea. So now apply the formula. We are applying same formula from first problem. The formula is n of C union T is equal to n of C plus n of T minus n of C intersection T. This we want to find this one. This is 70, that is equal to 37 plus 52 minus n of C intersection T. Calculate. This is equal to n of C intersection T imply 80 89 minus 70. So in N of C intersection T, the number of element is 19. So there are total 19 people who like both tea and coffee. Okay, next question, little bit tricky. Question number 7. This question is a little bit tricky because see the question, only tennis and not cricket, like that term is there. Now it is given in a group of 65 people, total 65, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket, and how many like tennis? So first we will denote the collection by some notation. C for the collection of people who like cricket, and T is the collection of people who like tennis. Now it is known number of element in C is equal to 40. Another, both cricket and tennis, that imply number of element in C intersection T is equal to 10. And another, number of total people, total in that group, total number of people is 65. Now before solving, let us draw one picture of this. Okay, total number of element in this set is 65. So suppose this is C and this one C and this one T. I am writing that this is C and this is capital T. Now in this set total 40 elements is there, and total area, this total is 65. In this intersection total 10 members are there, those who like both cricket and tennis. This is 40, this is 10, and this one we have to find the number of people who like tennis only and tennis and cricket both we have to find. This is tennis only portion, that's question mark portion, and tennis and cricket is this circular portion, this circular region is tennis and cricket. This one is for tennis only, tennis. This is common portion, those who like both tennis and cricket. This side cricket, this side tennis only. Now first we will find the number of people who like tennis. Now for that we know one formula, that N of C union T equal to N of C plus N of T minus of N of C intersection T. Now this is equal to total 65, N of C 40, N of T unknown, intersection has 10 elements. This imply N of T is equal to 65 minus 30. So N of T is equal to 35. So number of people who likes tennis is 35. This is the number of people who like tennis. Now see the figure again. So if I mark that portion, so this is the number of people who like tennis. Now if we subtract this portion, this red colored portion from this tennis collection, then we will get this portion. that number of people who likes only tennis. So that will be, this T is for total number of element in T is 35 and in the intersection 10. So if we remove those people who like both tennis and cricket, then the remaining will be only tennis, those tennis people, those who are liking tennis, that people will be there, those people will be there. So next write that the number of people who like tennis only, not cricket, that will be equal to number of element in T minus of number of element in C intersection T, and number of element in T is equal to 35 minus 10, that is equal to 25. So there are 25 people who likes only tennis. So there are 25 people who like only tennis. Next, the last problem of this exercise. Read the problem. In a committee of 50 people, 50 people speak French, 50 people speak French, 20 speak Spanish, and 10 speak both Spanish and French, both Spanish and French. How many speak at least one of those two languages? How many speaks at least one of those languages? Imply either Spanish or French or both. That imply if we denote this collection, suppose F is the collection, F imply collection of French speaking people, then number of element in that collection will be 50. Next, if S is the collection of Spanish speaking people, then it will be N of S is 20. So it is also given number of people who know both, who speak both French and English is equal to French and Spanish is equal to 10. We have to find number of element of F union S, either any one of this. F union S imply either F or S or both. So only apply this formula. F union S is equal to N of S plus N of F minus N of F intersection S, and this is equal to 20, this is equal to 50, this is equal to 10. So we are getting this equal to 60. So 60 people are there who speak at least one of those two languages. So this is the last problem of exercise 1.6, and this is the last exercise also. We will solve the miscellaneous problem of this chapter, mainly word problem in next video.